Hello everyone, my name is Sivgech Heang and I usually go by Siv, and today I'll be presenting my final project for our class Introduction to Remote Sensing, which focus on detecting the hurricane-driven water quality changes in Tampa Bay, Florida. So why look at Tampa Bay and why look at the turbidity? So hurricanes can dramatically disturb the water quality by resuspending the sediments and increasing the storm runoff. And they're also pushing the pollutants into the shallow estuaries. Tampa Bay is an ideal case because it is large, shallow, and ecologically sensitive. Last year, Hurricane Helene and Milton struck just months apart, which makes 2024 a powerful natural experiment. And instead of relying on in situ sampling, which is very limited in coverage and in timing as well, the remote sensing gives us a synoptic and repeatable way to monitor turbidity and at the landscape scale. This project demonstrates how satellite imagery can detect those post-storm changes quickly and consistently. Tampa Bay is one of the largest estuaries in Florida. It connects to the Gulf of Mexico. Right now they call it Gulf of America, and receives fresh water from several rivers, including the Hillsborough, Alafia, Manatees rivers. Because it is shallow and enclosed, the bay responds strongly to the sediments disturbance. Even moderate storms can cause rapid changes in turbidity, but with the two hurricanes back to back, we would expect to see much more dramatic system-wide impact. My research question is pretty straightforward. I just want to study how did the Hurricane Helene and Milton influence the turbidity and sediment suspension across Tampa Bay. For data, I use Landsat 8 and 9 operational land imager level 2, the surface reflectant products, which already include the atmospheric corrections. So I could just move directly into calculating and do the spectral index. I select two key dates. For pre-hurricane, I picked May 11, which has low cloud coverage, and then the post-hurricane, fortunately we have the October 18, which was 11 days after the Hurricane Milton, and the cloud also pretty clear at that time as well. And these 2 days capture conditions before and after the storm impact accumulated. So for pre-processing, it was minimal because the level 2 reflectant data is already corrected. So my workflow include only starting from clipping the imagery to Tampa Bay boundaries, creating a stack band layer, calculating NDTI using the red and green bands, applying the color ramps, and classifying turbidity intensity, and producing maps and histogram for statistical comparisons. This pipeline allows consistent comparison between the 2 dates. I use NDTI by calculating the red minus green divided by red plus green. I chose this NDTI index because the previous study have shown that the NDTI is very efficient in detecting the turbidity and sediment detection in the coastal environments. And it relies on the spectral relationship between the red and green bands, which responds strongly to the variations in suspended sediments. And higher NDTI value indicate higher turbidities as well. So NDTI especially useful in the estuaries like in the Tampa Bay area, where the color can shift dramatically after the major storm events. So before calculating NDTI, I examined the green band reflectance first, which we learned this in class in our lab 7. In the pre-hurricane image, the water appeared darker and more uniform. This typically signals like the water is clear with the minimal sediment loaded. We can also suspect like there are probably algae growth in there, but that's another story. However, in the post-hurricane image, we start to see that there's a bright green, yellow, and even reddish tone in a large scale, and this kind of show how like shallow the area and sediment plumes, along with the runoff from the inland watersheds that are pumped into the ocean in the Bay Area. The green band alone already suggests that an increase of turbidity or even some green growth like algae growth after the Helene and Milton hurricane hit the Florida. However, when we start moving into NDTI results, this is where the impact of Hurricane Helene and Milton becomes extremely clear. Let's start with the pre-hurricane NDTI map. So before the storms, most of the Tampa Bay show moderate to lower turbidity. The bay shows that relatively stable with the clearer water concentration toward the central and the outer portion of the estuary. High turbidity pockets are minimal and mostly restricted to the very shallow near to the shore area. This is expected for like large estuary during the spring condition. There are like calmer and lower runoff and fewer the disturbance. But when we shifted to the post-hurricane, the NDTI map, it changed dramatically. Almost immediately, we can see like the large regions lining up with the high NDTI values. This corresponds to the significant increase in suspended sediments, and the bright yellow, orange, and red tone indicate heavily disturbed water, and they appear across almost entire system in the Bay Area, not just near the shoreline. And one of the most notable patterns is how like far the sediment plumb travels. This instead of like remaining in the localized near the river mouth or the shallow bank, a plumb extended into the central bay and even toward the offshore area near the mouth of the estuary. This suggests strong winds driving, mixing with the tidal currents, disturbing the sediments more widely than usual. Another key is that the clustering of the high turbidity around the river inlets. This pattern strongly suggests that the elevated runoff following the heavy rainfall brought by the hurricanes. So the Hillsborough, Alafia, Manatee River likely carry the large pulse of like suspended material into the system, which the storm energy then dispersed. And if we compare like side by side, it also shows the changes even more strongly. Like the high turbidity zone expanded outward from the coastline into the central bay, which suggests that both sediments are resuspensions from the winds and the transport of the riverborne material downstream following the heavy rainfall. So overall, the contrast between these two maps, it highlights the system-wide transformation. The bay shift from relatively clear and stable condition in May to widespread disturbance in October after the hurricanes. So this kind of reinforced the idea that the consecutive hurricanes back-to-back like that not only increase the turbidity but can also sustain the elevated sediment loads for weeks, or even months after the event. And this NDTI map visually confirmed that the previous literatures describe about the hurricane impact by rapid increase of resuspension and increased mixing can amplify the sediment transport across coastal estuaries. So to quantify the visual patterns, I generated the histograms and pre-storm distributions is narrow and centered on more narrative and NDTI values. This indicating the water is clear. It's clear. But compared to the post-storm, the curve spreads outward and shifts toward zero and also lead to more like positive values, which kind of signal higher turbidity and greater spatial variation. This broadening of the distribution is also a strong numeric indicator of like storm induced disturbance after the hurricanes. And the numbers also reinforce the visual and the histogram finding earlier as well. If you look at the standard deviation, it's increased almost double from 0.18 to 0.28, meaning that turbidity have become more spatially variables. And if you look at the mean, it does give a slightly increase from negative 0.36 to negative 0.4. So together, this metric confirms as well that the hurricanes elevate the turbidity throughout the Bay Area of the Tampa. And for classifying the turbidity area, it showed most dramatic shifts as well, like from very low turbidity, it shrank from about 480 square kilometers compared to the moderate turbidity. It surged less than 1 kilometer to over 250 kilometers. And if we look at the high turbidity, the expanded system-wide, it's mean that the bay have moved into disturbed state, which elevated the turbidity, dominating the entire system following the storms. The results clearly show that the Hurricane Helene and Milton caused a major increase in turbidity across Tampa Bay. The shift from mostly low to widespread moderate and high NDTI values suggests the strong sediment resuspension from the wind and wave, which is expected in the shallow estuaries during the extreme storms. The high turbidity around the river mouth also indicated the increase of the runoff carrying the sediments and pollutants into the bay after the heavy rainfall from the hurricanes. And the broader NDTI distributions and the higher standard deviation also reinforce that water quality as well, that become more variables and disturbed after the storms. So all that together, these changes match with the previous studies and literatures that I review that describe that the hurricane impacts with the rapid mixings and bottom of the sediment disturbance and the movement of suspended material throughout the systems. So overall, the Landsat 8 and 9 and with the NDTI index were effective in capturing these changes. Even with moderate resolution, they provide a clear evidence of the system-wide turbidity increase, showing that satellite remote sensing is a reliable tool for assessing the post-storm water quality in the coastal environments. Thank you so much for listening and happy Thanksgiving.